The law of large numbers is a somewhat obvious, but nevertheless very important concept in statistics. And it basically just gives us a reason for wanting to make our sample sizes as large as possible, so that if we are trying to estimate some population parameter, our value that we get through our estimation is as accurate as possible. So let's take a look at what the law of large numbers tells us. Let's say that we want to estimate some population parameter. We'll call that mu. Maybe we want to estimate the average age of college graduates. This could really be any piece of data that you want to collect. Now, of course, trying to gather data on every single college graduate, whether we are simply just looking at college graduates in Louisville, or even college graduates in Kentucky or the United States, or if we were trying to be really ambitious and we wanted to calculate the average age of college graduates worldwide, no matter what our population is that we're interested in, it's not going to be very possible or even practical to try to survey every single person in that population and figure out how old they were when they graduated from college. Like I just said, it's not a practical undertaking. So of course that means we're going to have to take some samples to try to estimate this statistic that we're looking for. So what we are going to do then is we are going to collect many samples, and we're going to use the sample mean x bar to estimate the average age. The law of large numbers simply tells us that the larger our sample size for x bar, the closer it will actually be to mu, our population parameter. And that should probably make sense. If we can only survey 5 people and get their age from when they graduated from college, those 5 people, they might not necessarily be a very accurate reflection of the overall population. But if we increase that to maybe 50 or 500 people, the average age that we get from that sample will likely be closer, not likely, it will be closer to the population mean than the average age we got for the initial 5 people. And the law of large numbers just simply says that as we take more and more samples, as our sample size gets larger and larger, our average is going to get closer and closer to mu, which really shouldn't be all that surprising. If we go from a sample size of 5 to 5,000, let's say, we certainly wouldn't expect our average to go from more accurate to less accurate. That larger sample size of 5,000 is going to be far, far more accurate and closer to our population parameter than our original sample was. If there was some way to take not just 5,000 samples, but maybe we could get that up to 5 million, then our average age for our graduates would be even closer to the actual age. Of course, you are going to end up being limited at some point by time, cost, all of those things. There's no way that you could probably sample 5 million people. That'd be a little unreasonable. But the idea is just that the more people you can sample, the larger your sample size can be, the closer to your population parameter your sample statistic will be.